Sample problem 3.9 is similar to 3.8, but with just one major difference. Analysis of a sample of an ionic compound yields 2.82 grams of sodium, 4.35 grams of chlorine, and 7.83 grams of oxygen. What is its empirical formula and the name of a compound? Now, this is a tricky problem for most students, and let me tell you why. Initially you want to write up the formula and then use those grams as the subscripts, similar to what we did in sample problem 3.8. But you cannot use grams. Those numbers have to be in moles, right? So, for instance, let me give you an example. If you were to do this, Na 2.82, Cl 4.35, and O 7.83, and then pick the smallest number and then try to get an empirical formula that way, you would be incorrect. This is not correct, okay? These numbers have to be moles. So that's our first step here. I know I've got 2.82 grams of sodium, and the molar mass of sodium is 22.99 grams of sodium in 1 mole of sodium, and I got that directly from the periodic table. And so I'm doing a conversion here so that I can get moles so that we can figure out the empirical formula. So I've got 2.82 divided by 22.99 equals, so I know I've got 0.123 moles of sodium. And I got to do the same thing for chlorine and oxygen. I've got 4.35 grams of chlorine. Molar mass of chlorine is 35.45 grams of chlorine in 1 mole of chlorine. And again, that's directly from the periodic table. That's just the molar mass of chlorine. Those are going to cancel, and I'm going to be left with, let's see, 4.35 divided by 35.45. I got 0.123 moles of chlorine. And then oxygen, let's see, we've got 7.83 grams of oxygen from the problem. The molar mass of oxygen from the periodic table is 16 grams of oxygen in 1 mole, so 16 grams per mole. Grams cancels grams. 7.83 divided by 16 equals 0.489 moles of oxygen. And now we can write our little formula with the decimal numbers, right? So now I've got sodium 0.12. Oops, I didn't put my Na. I was doing the symbol for nitrogen. So sodium 0.123, chlorine 0.123, oxygen 0.489. And now I have to ask myself which ones of these numbers are the smallest, and there's two, right? 0.123 are smaller than the 0.489. So for sodium, I've got 0.123 moles of it. I'm going to divide it by the smallest number, which is 0.123. That's going to equal 1. For chlorine, I've got 0.123 moles divided by the smallest number, which was 123. And so that's equal to 1. And then oxygen, we have 0.489 moles divided by 0.123. Let's see, what's that equal to? 0.489 divided by 0.123. Oops, I think I did something wrong there. 0.489 divided by 0.123. There we go. And I got 3.975, which is approximately 4. Anytime you're within a tenth of a whole number, it's okay to round that up. Now, if that would have been 3.6, I would have had to leave it at 3.6 and then do our steps to get our empirical formula. But now I'm going to see, I've got Na, and I've just got one of them, Cl, and I've just got one of them, O4. So there's my empirical formula for this ionic compound.